So the most common way to transfer control in our assembly environment is to use conditional jumps. And the idea is that first we need to check some sort of condition, and then based on the condition we can create a jump to a different alternative location. If the condition is false, the jump will not execute. So let me make a quick demonstration, and we'll do something very similar to what we did in our first version of this code earlier. So for example, we can say move into register AL value 5. Okay, so this instruction of course is using immediate operand. Then later on we can compare AL and 5. Okay, and then we can say jump if equal, and we can jump to a certain label, for instance done, something like this, and we'll set the done label over here. And for the demonstration we can just populate our program again with a few no operation instructions, which basically do nothing, just provide a way to fill in space in the code segment. Okay, so this is an example of a condition. So the compare instruction compares two operands, basically register AL and the byte size value of 5, and if they're equal, this is jump if equal, we can be jumping over here. So I'm expecting that our code will jump if we do this. So if we say build and press F11 to step into the code, we can now step F10, and the comparison of course will update the flags. So based on the results of the flags, jump if equal, we're jumping to this label. If I stop the debugging and now modify it to jump if not equal, okay, so this is an alternative version of this type of comparison, jump if not equal. Then if I run this again, let's build this first and then run, step into, and one more time F10, F10, and so this time you see that because AL equals 5, we are not jumping. So this is an idea of conditional jump. Only if condition that we're trying to test with respect to the result of the previous command that updated the flag register, we will jump. So that's the nature of conditional jump. So there are quite a bit of conditional jump instructions. Each conditional jump instruction takes a single operand containing the target address. So basically it just maps itself to check specific flags, and based on whatever flags you're trying to test with your instruction, you will be conditionally jumping. So this is a longer list of all of these instructions that are available. Examples that we can check the carry flag setting. We can check if we had any results that are 0. We can combine different flags. We can check the sign flag, and there is this parity flag also, which can check the result of the parity condition. And the parity flag is basically a combination of that's trying to verify whether there is an even number of bits that are set to 1 and of course set to 0 in a specific data type. So this is the parity flag will be set if there is an even number of 1s and 0s. If the number of them is odd, that will be a false parity. And the implementation of the parity flag is basically using the exclusive OR and inverting the result. So basically 2 1s becomes 1 after applying exclusive OR, which will of course result in 0, but this inversion bubble converts it to 1. And likewise, if we have both zeros, we also have exclusive OR gate will yield a 0 right here, but the bubble makes it 1. And when there's a difference, it becomes 0. So this can be further combined, and this is the idea of the parity checks. So this is very important table right here, jumps based on comparison of two values. It is another place where we have to pay special attention to the data types with respect to whether we're working with signed values or unsigned values. So of course we can compare values that are both signed and unsigned. Typically, a high-level programming language compiler will give you a warning if you attempt something like this. In assembler, it's our own responsibility to remember to use a specific set of instructions with respect to signed comparisons, comparison of signed values, and comparison of unsigned values. So, for example, there's this set of all possibilities: jump if equal, jump if not equal, jump if greater, or jump if not less or equal, and so forth. So this is basically L and G stand for less and greater, and N stands for not equal. Okay, and equals E stands for equal. In the unsigned set of conditional jump instructions, instead of using G and L for greater and less, we use instruction mnemonics which abbreviate above and below, which corresponds to A and B. So this is for unsigned comparisons, and this is for signed comparisons. So let's take a few examples. I'm just going to stop my debugging session right here. And so, for instance, if I was comparing this and thinking about signed comparisons, for instance, let's change it to -5, okay? And now I am comparing AL with 5, but this was set to a negative value. Of course, I'm trying to compare here signed values, so I'm supposed to use these instructions. And so if I want to jump if, let's say that we can maybe add some comments right here. We could say if, for example, what we want to test is AL is less than 5, okay? If AL is less than 5, then we want to be able to jump, right? So then jump. And less than is done with instruction mnemonic JL. So this would be less than. So you see how basically the two operands are provided to the comparison instruction, but the actual comparison is interpreted by the JL instruction. So this is jump if less. Okay, so jump if less, if AL is less. Of course, I'm expecting that AL is negative and 5 is positive, so we should be actually doing our jump. So let's do this. Okay, so we build this. Again, press F11 to step into our code. Then just press F11 or F10 to step over. And right here, I'm expecting that negative value in register AL right here, which is hexadecimal FB, which is -F5. If we step over, yes, of course, we're jumping. But it would be a mistake. So I'm going to stop my debugging session, and it would be a mistake for me to use, in this case, instruction JB. So JB is jump if below, which is just like jump if less, but this is specifically for unsigned values. So that is that would be incorrect version of the logic here. I don't, so if we're trying to do a sign comparison, this may not work correctly. So F11 to step into this, and again I just press F10, 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 and this time it didn't work. So that's a big difference between these two versions. So remember, you are responsible for remembering what is your attempt to compare. Are you comparing values that can be both positive and negative? Then this is the set of your instructions. If you're comparing just unsigned values, only positive and zeros, then this is the set of the instructions that you need to rely on. So again, jump if equal, the same in both sets. Jump if not equal, the same. Jump if greater, jump if above. So just remember that this is the difference. Jump if less, jump if below. Okay, and the rest is just jump if not greater or equal, or jump if not above or equal. So these are other types of combinations that are available in these comparisons.